Hey, this is Mr. Warden. This is going to be a video key of exit ticket 23.2 for geometry. So I am the key. So you'll have these questions, of course, the usual questions to answer. So there's some information for you to review. And whenever I give you this information, I intend for you to take a look at it. And I know you do. So that's great. These are definitions about planes and lines and their relationship to each other, particularly parallel ones. So if you have a line and a plane that don't intersect, then they are parallel. If you have parallel planes, then they don't intersect anywhere. That changes in non-Euclidean space, but we're not dealing with non-Euclidean space. This diagram here shows two lines that are located in two parallel planes. Although the planes are parallel, the lines are not parallel because A, B, and C, D do not determine a plane. These lines are called skew. They don't intersect and they are not parallel. So they never touch in 3 dimensions. These skew lines are two lines that are not coplanar. Okay. Now, there's some more information for you to read. So there's some properties to consider. If two planes are perpendicular to the same line, they are parallel to each other. If a line is perpendicular of two parallel planes, it is perpendicular to the other plane as well. And if two planes are parallel to the same plane, then they are parallel to each other. That's a variation of the transitive property. You might have recognized it. If two lines are perpendicular to the same plane, then they are parallel to each other. And that's also a little bit of that's a variation on if two lines are perpendicular to the same line, then they are parallel to each other. And if a plane is perpendicular to one of two parallel planes, it is perpendicular to the other one as well. And if two lines are parallel to the same line, then they are parallel to each other. And that's transitive property. Okay, so if a plane contains one of two skew lines, it can contain the other. So refer back up here to the comment about skew lines. Well, skew lines are by definition lines that are not coplanar, so that's false. If a line and a plane never meet, they are parallel. Well, we can refer back up here to this definition. By definition, a line and a plane that don't intersect are parallel, and definitions are reversible. So that is true. If two parallel lines lie in two different planes, then the planes are parallel too. Well, here's the thing. The lines can be parallel, but the planes could tilt this way and that way and still have those parallel lines go through them. You could have planes that intersect each other somewhere else and have parallel lines in them. In fact, you will have an infinite set of those. So that's a false statement because the planes need not be parallel. They could, you think of it as swivel. Not sure how to spell swivel. I think swivel back and forth on the parallel lines like a hinge. Okay, so think of it as like a door. So a door has like a frame, okay? And you could have a parallel line on one part of it that's parallel to part of the frame, but the door can swing back and forth. And so the plane of the door and maybe a plane of another door on the other side of the hall could be parallel, but they don't have to be. Okay, so because the door can swing back and forth, but the lines can stay parallel. If a line is perpendicular to two planes, then the two planes are parallel. Okay, if a line is perpendicular to one of two parallel planes, it is perpendicular to the other one as well. If two planes are perpendicular to the same line, they are parallel to each other. So property 1 is really the one that applies. So you might have to read a couple of these. That is true. If a plane and a line not on the plane are both perpendicular to the same line, then they are parallel to each other. That is going to be true. So a plane and a line not on the plane are perpendicular to the same line. They will be parallel to each other. All right, I hope that helped, and I will stop.